So I'm going to just talk briefly here about inverse functions. And we've already talked a bit in class about what inverse functions do and how to find them. But this is just a nice little revisit. So basically what inverse functions do is they undo functions. So they're the thing that if I have some function f, remember you can think of that as a machine. If I plug in x, out pops some output. We usually call that output f of x. What an inverse function does is it basically takes this output, puts it back up through the machine in reverse, and out is going to pop x. But it actually becomes a new machine. So it's like the machine flipped over. Like if you took it and rotated it 180 degrees. So if you plug in f of x, out is going to pop out x. Whatever you put in here is going to be the output. If you put that output in here, that's going to be the new output here is going to be what the original input was. They undo each other. Examples like x plus 5 and x minus 5. So if I have a function f of x is x plus 5, its inverse, the thing that undoes that, and this is how we write it, is going to be x minus 5. So with that in mind, how do you go about finding a function? If it exists, remember it doesn't even necessarily exist in the first place. So in class we kind of came up with some steps for how to do this. And so the first step was replace the function notation with y. And this isn't really necessary, but it just kind of helps a little bit. So I'm going to have this function f of x is equal to, let's say, 3x plus 5. So the first thing we could do, if you want to run it through a flowchart, replace f of x with y. So I'm going to rewrite this as y equals 3x plus 5. The next thing that we do then is we switch the x and y. Literally what we're doing is we switch all the outputs and all the inputs. So this gets rewritten as x takes the y place, y takes the x place. So again, what we did is we literally switched the input and the output. This is us flipping that machine over. And now we just do some algebra to get y all alone. We basically solve for y now. And what we're doing there is then we're getting it in terms of the output. Solve for y. And so then we just do some algebra. I'm going to subtract 5 from both sides. X minus 5 is 3y. Sorry, this is problem 3. And then still getting y all alone. I'll divide everything by 3. So x minus 5 over 3 is y. And then we're just going to kind of do some bookkeeping, some clerical tasks. We're going to put it back in terms of f of x. So we're going to replace the y, the outputs, replacey. We're going to replace the y with the symbol for the inverse of f, which is f inverse of x. So instead of y, this is going to say f inverse of x. That's like a -1 up there. And that's equal to, I'm just switching the order, x minus 5 over 3. So there's one example. And remember then, the way that we check it is we plug this into that, make sure we get x. We plug that into this, make sure we get x. Here's the nice thing about having a process over here on the right-hand side is if I have an idea of what my process is, what I'm going to do in order to make this happen, I can just keep the process alive and just try and use it to solve any problem with. So let's try a problem that's a little more difficult than the one that we just did, and I'll just make one up here. So let's say we have f of x is I like 3's for some reason. 3x minus 7 over 12. So that's our problem. We want to find the inverse for that if it exists. So replace f of x with y. Okay, I can do that. switch the x and the y, switch the input and the output. So rewrite it as, instead of a y here, there's an x. Instead of an x there, there's a y. Again, that's us flipping that machine over. Solve it for y, get it in a form that we can use. So notice this whole thing's divided by 12. Multiply both sides by 12. I didn't need those parentheses. 12x, it cancels over here. Equals 3y minus 7. Add 7 to both sides. 12x plus 7. Sorry about that again. Is 3y. Divide everything by 3. Y is 12x plus 7. The whole thing's divided by 3. So that's solving for y. Now replace y with f inverse of x. All right, so f inverse of x is this. 12x plus 7 over 3. So I can just use this process again and again. The bulk of the work is the algebra manipulation. You know, solving it for y once you've switched your input and your output spot.